So we'll be getting into a new feature of rational graphing now called the horizontal asymptote. And in some ways it's similar to the vertical asymptote, right? It's this dotted line, and oftentimes you don't want to cross it. In that sense, it's a little different. The vertical asymptote you can never cross, but sometimes you can cross the horizontal asymptote, although often you will not. But the way you find the horizontal asymptote is a little bit different than the vertical asymptote. Take this graph on the left right here. If I want to know just the vertical asymptote for this guy, I look at the bottom, see that factor right there? I say x plus 2 equals 0, or can't equal 0, whichever way you think about these domain restrictions. And then you solve it and say x equals -2. That's the equation of the vertical asymptote. So you would write that in here, x equals -2. Okay, and while we're at it, why don't we just do this one over here on the right? That would be 3x minus 4 equals 0 for the vertical asymptote. Means 3x equals 4, means x equals 4/3. So that's how you find vertical asymptote equations. We know that already. The way you find a horizontal asymptote is a little bit different. Oftentimes, you just look at the equation and categorize it as one of two scenarios. And here are the two scenarios. Either the power of x on top is weaker than the power of x on bottom. Okay, in this case, there's no x on top, so obviously that's weaker than the x on bottom. But a similar scenario could be x minus 3 over x squared, right? You see there's a power of x squared on the bottom, but only an x on the top, so the bottom is stronger. In cases like these, these are bottom-heavy cases. I think that's how we describe them in class. When the power of x is stronger on the bottom, the horizontal asymptote is just y equals 0. That's it. There's no calculation involved. And you can see that right here on the graph, right? You have a horizontal asymptote running along the x-axis. But in other cases, look at what we have. We have a power of x that's equal on top and bottom. I'm not talking about the coefficient, the 2 versus the 3. I mean the power of x, the exponent right here. See, the exponent is 1 in each of those cases, just like it would be equal if it was x squared minus 3 over, I don't know, x squared minus 16, or 2x squared minus 16. They're all x squareds in this case. So when your powers of x are equal on top and bottom, you have a different horizontal asymptote. And the calculation for this one is also pretty easy. What you do is you just take a ratio of the coefficients. Okay? And by the coefficients, I mean the leading coefficient, the one that's in front of that x term that we're looking at. So in this case, it's just 2 over 3, and we would write that right here. Y equals 2 over 3. So horizontal asymptotes are actually pretty easy to figure out. If you have a graph, you can just look at it and usually figure out where the horizontal asymptote is. Or if you have an equation, you just look at either the ratio of the coefficients, or if the x power is stronger on bottom, then the horizontal asymptote is just 0. Now, the last part of this problem is the domain of f, but remember, the vertical asymptote really defines, the vertical asymptote is your domain restriction. So if we want the domain of f, we are talking about everything aside from the distriction. So this would be -∞ to -2, union -2 to infinity. And we've played around with these before. Likewise, this one on the right would be -∞ to 4/3, union 4/3 infinity, right? The domain is everything except the domain restriction.